Now, in order to have good restorations, we have to have good preparations. And one of the critical aspects of a good preparation is the core buildup. And we need to understand the definition of a core. And a core is that part of a preparation for an indirect restoration consisting of restorative material. The primary purpose of our core buildups is to replace enough missing tooth structure to create ideal retention and resistance form in our crown preparations. Understand it's really good practice to always remove existing restorations that you didn't place. Okay? It allows you to facilitate cavity inspection, and you create mechanical roughness, which will help ensure the core retention. Cores can either act as a simple space filler or a structural buildup. The less tooth structure, the greater the mechanical demands will be on the core, and this is why you must choose your core material carefully. This is an interesting study by Lindquist looking at microleakage of luting agents and using crown foundation materials. And what he found that core restorations of either amalgam or composite tested using modern bonding regimens exhibited less microleakage than an ideal crown preparation in dentin alone when luted with a resin reinforced glass ionomer. And this is just a photograph from his article. And you can see the foundation filling is in F. The metal crown is in black. He embedded these teeth in clear resin and soaked them in dye. And he found that there was absolutely no microleakage observed, especially when the foundation fillings were used. So let's return to this original question and this original image that we talked about. So just because you can use bonded luting agents doesn't mean you should. It's just one part of the equation. There are definite rationales for the core buildup. Okay? It allows for a path to draw without removing more tooth structure. We don't have to get past undercuts. This is a critical one. Provides immediate seal of the deepest dentin. It makes it much easier for the lab to fabricate a substructure to support the overlaying ceramic, be it metal, be it zirconia. And for us, the future treating dentist, it facilitates the removal of the restoration in the future if necessary. Because there's nothing more frustrating than going through 10 burrs trying to find a cement line because there was no core placed. Some of the things we want from our core material, okay, we want to be able to prepare it relatively soon after placing it. It has to be strong. It has to withstand the withdrawal forces of not only of our impression materials, but the removal forces of our temporary crowns later. And of course, it has to survive the mascatory forces of the restoration over the life of the restoration. So to me, the ideal properties of a core material has to be relatively fast in setting time, has to have high mean bond strength, low volumetric shrinkage, high flexural strength, and it needs to cut like dentin. It needs to feel like a tooth. Again, the physical properties of our core become more important as the residual tooth structure decreases. It has to have adequate compressive strength, as well as sufficient flexural strength. It needs to, as Lindquist showed, resist the leakage of oral fluids at the core-tooth interface. And this requires that we're able to bond it to the tooth structure. Now, one of the critical things that many people don't address is that the thermal coefficient of expansion and contraction have to be similar to the tooth. The bottom line is the amount of shrinkage related to the amount of filler content in composite resin. Okay? A reduced amount of filler will cause greater shrinkage. For this reason, it's necessary to avoid using flowable composite resins as our buildup materials because of their low filler content and their reduced mechanical properties.